Imagine drifting through the silent vastness of space when suddenly you feel yourself stretching. Not metaphorically, but literally. This is the eerie reality of tidal forces, the stretching and squeezing of objects under the pull of gravity. But how does it work? Tidal forces happen because gravity isn't uniform. The side of an object closer to a massive body, like a planet or star, feels a slightly stronger pull than the side farther away. This difference in gravitational pull causes the object to stretch along the line pointing toward the massive body and compress along the other directions. It's why Earth's oceans bulge outward on both the side facing the moon and the side facing away, creating two high tides each day. But tidal forces don't just move water. They also flex the solid crust of Earth itself, subtly lifting and lowering land masses every day. Take this idea into deep space, and the effects become even more dramatic. Near a black hole, the tidal forces are so intense they could rip apart anything that dares approach too closely. This is the infamous spaghettification, a term physicists actually use, where an object, or even a person, would be stretched into a long, thin strand of matter, pulled apart atom by atom as the gravity difference between head and feet becomes catastrophic. But tidal forces aren't just agents of destruction, they're also cosmic sculptors. Around giant planets like Jupiter and Saturn, tidal forces shape the fates of their moons and ring systems. Moons like Io, for example, experience such extreme tidal flexing from Jupiter's pull that their interiors heat up, driving volcanic activity, making Io the most volcanically active body in the solar system. Saturn's rings, too, owe their shimmering beauty in part to tidal forces, which prevent larger moonlets from forming by pulling them apart when they get too close. Tidal forces, then, are everywhere, shaping planets, moons, and even galaxies. They remind us that gravity isn't just a pulling force. It's a dynamic, stretching, squeezing, sculpting force that can both create and destroy. Whether quietly lifting Earth's crust or tearing apart stars at a black hole's edge, tidal forces are the universe's invisible hands at work.